Okay, so we're going to try to find the maximum and minimum values of some function. This right here would be our objective, your function that you're trying to find the maximum minimum of. So your f of x comma y. Subject to, so that's the constraint that you really have no control over. So subject to this constraint, that's our goal. And so in order to do that, we'll go ahead and do our Lagrange multipliers for this problem. And so for the Lagrange multipliers, it's the same setup each time. The gradient of your objective function at whatever point it is that might be a maximum or minimum will be equal to lambda, or some constant, times the gradient of your constraint function at that point. So that's the first setup for our Lagrange multipliers. So let's go ahead and write out those equations here. So the gradient of my function f, if you're looking at my objective here, the gradient would be 2y e to the 2x times y, comma, and then our gradient, so now we're doing a partial with respect to y. So the derivative of e to the something is still e to the something, and then I'm multiplying by the derivative of that argument with respect to y, equals lambda times, now I got to do the gradient of g, so partial of g, now I'm looking at my constraint. Now in this case, when you're thinking about it, it's not, even if it's not written as a g equals something, you take your constraint and just make sure that 0 is by itself first. And then once you have that, what you have remaining is called your constraint, and we can now call it the g. Alright, so that's what we're at for that one. So our gradient of g would then be partial with respect to x is 2x, and partial with respect to y is 2y. So what we'll do is we'll list out our equations. So the equations that we're looking for, the first equation that I have is 2y e to the 2x times y equals lambda times 2x. Alright, that's the first component. My second equation I have would be 2x e to the 2x times y equals lambda times 2y. And then your third equation is always going to be that same constraint that we already started off with, which was the x squared plus y squared minus 16 equals 0. So those are our three equations, and then you want to try to solve those. So there's multiple ways that you can do these. There's always going to be more than one way. In my opinion, what I'm going to choose to do is I'm going to start at the beginning here, at the very first equation, and I'm going to isolate that complicated term, because e to the something looks a little complicated. So if I isolate e to the 2xy, I would end up with, I'm basically dividing both sides by 2y is sort of what we're doing right there. And when I do that, I'll end up with a 2 canceling, and I'll get a lambda times an x divided by a y. And then I'm going to choose to take this and plug it into my second equation. So now from my second equation, I get 2x times, and instead of e to the 2x y, I'm going to get lambda times x divided by y equals lambda times 2y. Then we can start to simplify even farther. So if I divided both sides by 2, the 2 would cancel. So that's one thing that I just noticed that might be easier. I could also realize I could divide both sides by the lambda, and so the lambda would cancel. Again, just to try to simplify what we've got. So then it looks like I ended up with an x squared divided by y equals a y. Now if I multiplied both sides by y, that gave me x equals y. So, x squared equals y squared. So then when I take the square root, I end up with x equals plus or minus y. So all of that process was when I first started off with the first and second equation. So that was me using the first and second equation. So now we're going to want to use that same, whatever we found, the x equals plus or minus y, into the third equation, so that we can get a numerical value, or actual ordered pairs. So let me rewrite what we have. We've got x equals plus or minus y. And because we have x equals plus or minus y, I'm going to choose to make an x equals y over here, and I'll deal with the x equals, the x equals negative y later on. You just do one at a time, because otherwise it can get kind of confusing. Okay, so that's what I'm dealing with, and I want to look at my third equation. So I go back and I look at my third equation, which looks like I have the x squared plus y squared minus 16 equals 0. So that's what it is I'm dealing with. So I've got the x squared plus y squared minus 16 equals 0. And if I plug in my x equals y, this will become now a y squared, plus y squared minus 16 equals 0. What I did is I just replaced all of my x's with the x equals y, which just is going to simplify some things. So now I'll end up with a 2y squared minus 16 equals 0, which will give me y equals plus or minus the square root of 8. So the ordered pairs that I have from there is I've got a couple of different ordered pairs. If y is the positive square root of 8, then x, in this case, we're looking again at the x equals y, which means x would have to be the same thing. Okay. Another ordered pair was we had an option for y to be negative square root of x, or sorry, square root of 8. But again, we're looking at x has to be y, so then x would have to be the same thing, which would be the square root of 8. So there's a couple of ordered pairs I got. So now we're going to go back to the x equals negative y, and I'm still going to look at equation 3 from the previous page that I had. I'm still going to look at my equation 3, and I'm going to try to simplify this guy. So one more time, now my x's are going to now be replaced with negative y. So slightly different, a little bit more complicated, but not too far. So x is going to be negative y, which now I'm going to have a negative y squared plus a y squared minus a 16 equals a 0. So again, that simplifies kind of nicely because the negative squared ended up canceling. And I still got y equals plus or minus 8, square root of 8. Okay, so let's list out our ordered pairs. So if y equals the positive square root of 8, then what I'm looking at, I'm looking from here, I'm kind of going back up to here to compare where it came from. If y was the positive square root of 8, then x would be the negative whatever y is. Alright, so if y was the negative square root of 8, then x would be the negative of whatever y is. So we got sort of different ordered pairs there, which is kind of interesting. So here's what we got. We've got these 4 ordered pairs that we're dealing with now. And with those 4 ordered pairs, we're trying to, these all came from Lagrange multipliers. So my next step is to try to figure out which one is the maximum and which one is the minimum. So in order to do that, let me rewrite our ordered pairs over here. What I want is our square root of 8 and square root of 8. And then I also had negative square root of 8, negative square root of 8. I had negative square root of 8, comma, positive square root of 8, and positive square root of 8, comma, negative square root of 8. So those are the 4 ordered pairs that I found. All right. The other thing we're thinking about is we want to go back and look at our original function, our objective. What was the goal here? So this was our our objective, right there. Okay. That's what we're trying to figure out what a max and a minimum is. So from there, that is the function we're plugging in our potential max and mins. So our function is f of x comma y is e to the 2xy. So that is what we're going to plug in our ordered pairs into that function. So for each one of these guys. All right, so we can do that. I'll go ahead and do that. All right, each one. So everywhere I see an x and a y, I'm going to replace that in this case with the square root of 8. And that'll become, now I have an e to the 2 times the square root of 8 times the square root of 8, which became e to the 16. Now for the next one, I would get e to the 2 times negative square root of 8 times negative square root of 8. The negative would cancel, and I would get e to the 16. Okay, so for the next one, I would get e to the 2 negative square root of 8 times the positive square root of 8. So the negatives don't cancel, and I got e to the negative 16. And then the same thing for that fourth one, I got e to the negative 16. So then the goal is to just kind of give yourself a conclusion. So what did I find out? It looks to me like our maximum that we found, the highest number, is what we're looking for. So that, of course, is our e to the 16. So our maximum, let's maybe write that a little bit nicer. Our maximum value is e to the 16. And this value occurs at the ordered pairs, root 8, comma, root 8, and negative root 8, comma, negative root 8. It's okay to have more than one maximum. All right, and then, of course, it looks like our minimum is e to the negative 16. And this minimum definitely occurs at, again, in this case, 2 different points. Negative root 8, comma, positive root 8, and positive root 8, comma, negative root 8. So this is that final conclusion from the Lagrange multipliers. Ta-da!